Hello everyone. I was watching recently at LinkedIn. I saw this interesting poll. What is your favorite energy modeling interface? And I was thinking, oh, this was very cool initiative. However, in the time when we're trying to move to Dynamo and BIM, I was thinking, what is the most integrated software with Dynamo and Revit? And I think I will start now this kind of action with the other people, so they will try to challenge me and we'll move everything forward. So I was sitting at my desk and looking at some honeybee, and I was thinking, if I could come up with some cool plugin and uh, make up some name, I think I would like to use it honeybee. However, it is not possible because Mustafa already was the first one, and my daughter also is big fan of his tools, so I was a bit left alone and I think, oh, I have to come up with some different approach. So I collected the team. It's me and Jakub Ziółkowski, and we spent one day in 1st of May, and we think what we can achieve. And I was trying to come up with the names Spring Mantis, Butterfly. I wish I could use Honeybee, but I think everything was already in use. So I was very angry. And then Tasmanian Devil came to my mind, and I was thinking, oh, in this case I have to use Tas. The name will match, and let's see what we can use and how we can integrate this with Revit. So idea behind this, how we can minimize all the action and how we can control as much as possible from Revit and Dynamo. And here I just proof of concept. I just created very simple box. However, this can be used in a complex way. I just would try to show this on the simple model and use Dynamo script to show the idea. So here we have just simple geometry with different type of walls. So it's this wall below grade, so we have some kind of a grade from this side. We have here external solid wall and solid roof. And at the moment I didn't put any space, so let's start. We're gonna first of all put the spaces. So analyze space. Let's put from level 1 to level to level 1, and we can place them automatically. Okay, we have now 4 spaces left. Usually what I do, I use now Dynamo script which gonna number all my spaces from 100 till the end at each level. So let's start with Dynamo. Okay, here we go. Okay, we have here the script, so we have to just select the level and run it. So at this level everything will be numbered from the beginning till the end. And I like to use the script because later on I have good control over my levels. Okay, so let's tag it now. Annotate, tag all. Okay, so this is the first step. We have now all the spaces calculated from 100 till the end. I don't like starting from 0 because later on the digits are not nicely sorted. So okay, the next step is now we're gonna produce the GBXML, and this step has to be actually done manually so far. So I think the good approach is always to check if we don't have any warnings here, and very often we can see all this kind of redundant spaces of some issues. So usually we should prepare the file. It is nice and clean. Okay, and there is the one step we have to follow. We have to manually import the file the moment the automation does not allow for it. Here I prepared the um, two empty task files from the template. Those are set up to be used for the part L, so I will just show this example for the British part L where I'm gonna use NCMan data. As we can see, this is the empty file, so I'm just gonna import our XML spaces and okay. Okay, here we have the file, and I just want to show you at the moment we were exporting the file as it is, and I just want to show you that now we can move lots of data from Revit file that actually GBXML does not contain yet. So at the moment, as you can see, all our new construction that are used are saved here, and we don't have the proper thickness. We don't know which one is transparent, solid, and so on. So now we're gonna try to use for all this Dynamo. So here we going again. At the moment I'm using version 0.92. Okay, we define the spaces, we have the numbers. Now we have to apply some internal condition, and at the moment I just gonna use um, part L definition. So let's make those two offices, and I already have the task internal condition, and those two maybe we're gonna make toilet. Okay, so now we apply to both of them our internal condition types. So this should be now used in our model. So let's go back to Dynamo. And all what it should do, it should now allow us to apply to appropriate groups our internal condition. And okay, so here we go. So here is our new set of task nodes. T3D is 3D modeler, and here we have our components. Usually the logic goes the same as we do in Excel when we can program it. So we always in the first place open documents, then open the building, and from building we're getting the name or the zone data or zone elements and so on. I think people who are using tasks will be very familiar with all this naming. So I found the file path, so we're selecting our file, which is here. Then is the documents. Do we want to open and save after changes? Yeah, it's true. Then we're going to building, and here what we doing, we're just reading our internal condition from Revit spaces, and then apply according groups within the task. And in the next step here, what we're doing, we're taking the roof, floor, the walls, and I think here I have windows, and depends if we have glazed or solid, we apply appropriate transparent or internal shadows and so on. Okay, so let me run this file now. We can see the file is opening here and running. Okay, this is now complete. So what we did, we just now save all the building elements, thicknesses, transparency, and so on. The next step, what we're gonna do, I'll just freeze this. We're gonna just run the shading calculation, So we need to define what is our name of our building designer file. So we want to simulate from 1 to 365. This for the shading calculation. Step 15, zone set, we want to merge, and then we want to assign the construction and internal condition. And at the moment I'm using part L, so those are coming from NCM data. So let me just run this, and now we should see here the TBD file should open, and the calculation should start. Oh, here is TBD file, so we can see the shading calculation has started. I think I'll move this a bit because we're gonna see when it's done. Okay, it's completed. We see TBD is closed, so the file is now with the data. So I think we can also close this. And the last step is we need to now get the data from the file. So TAS now generated building file, so which means we have now proper area and TAS ID and GUI. So I think we can recover this data and bring it back to Revit. And we know the order of the zones in GBXML is sorted by element ID, so I can use the same sorting and bring all the data. Okay, this is fine. So I can close this file now, and we should be able now to see. Okay, so we can now see the simulation area, and this area will be different to the Revit area because at the moment I use just normal thicknesses, but I'm using the parameters in each element to define thicknesses. So in this case, for this wall, I was using parameter description 150. So as we can see here, this area from the simulation should be smaller than area calculated by Revit. So Revit calculates 2898 and we have 2813. And also at this stage we should have also the GUI and TAS ID. So what we did, we just established now the link between simulation and Revit. And let's see now in the files. So if we open once again our 3D file, okay, we can see now let's sort it. We can see now all our used construction are not anymore 0.1, but they have, each one have thickness. And for the below grade we have ground tick box attached, and yeah, and also for the floor ground, and this for the wall. And I think for the windows we have now transparent internal shadows, and also the frame percentage. We have 0.78 and 88 in each of the windows, so we also took over the frame sizes from Revit to our simulation tool. So this is cool. And when I open now TBD, just to check it, we should now have the building with simulated shading. So if I click on shading, we can see all the shades are available because the simulation was done. If I go to any space, at the moment nothing is sized yet because we didn't simulate it, but we can see that each space is now applied to the correct group, and we can see that those two are toilets and those two are offices because I use the same name to match the database from NCM data. Okay, I will close it. I just opened those files just in order to show you, but I will finish this process now. So let me now open Okay. Okay. Here is the file for the simulation. I just found this kind of funny things that if you in Dynamo, if you call /t, will make the space. I'll just show you here. That's why I use the string. So what happened here? I'm just opening my TBD file. I gonna run and save. I gonna run from 1 to 365. I don't want to open the results file. Aperture, no. Or I will do everything. So I want to ask for aperture, merge file, and take the weighting factors. I think we need them for part L. And this is my name of my output file, TSD. So as you can see at the moment, I don't have any TSD. It's only TBD and T3D. Okay, so I will just run it now. And what it should do, it should open, TBD is open, and now it should start simulation. We can see it started, and TSD file will be generated. So we can see it's running now. So it's doing the hourly simulation for the whole year for this for zones, with all this kind of complex maximum output that is available. Okay, this is completed. Okay, so I think I can close this. And now we can I usually close the Dynamo because I notice sometimes Dynamo is a bit tricky, and when you close, sometimes you don't close, it remembers the previous steps. So let's see. Now in TBD, we should see our heating and cooling loads already simulated. Yeah, so we have see heating and cooling. So now let's bring all the results back to Revit. So okay, and this is a bit complex script, but what we're trying to do, we're trying to bring all the data back to the Revit just so it's easier to see what's happening in each space. Okay, here all we have to do is just we need to select the results file. So okay, and I think this should be it. So just run, and this should just bring all the data back to Revit. Okay. Okay, simulation is finished. Let's see if we have results. We can see we have warning here because in TAS there is two methods of calculation: cooling design day and the simulation data. At the current stage, we didn't set up the cooling design day, so only the simulation data is taken. So I think we should still see results. At the moment the file is set up, that will take either of those. So at the moment we have only one, so we still should work with one. So let's come back to Revit. Okay, perfect. So now we can see in Revit we imported 12th of May at 11:41 p.m. Yeah, it's very late here. And our lighting load is 293 watts, small power and occupancy. And all this data should come from the NCM standard data. However, if you want, we could define the internal condition and control this. Those are this kind of external plus solar data, which is solar, building heat transfer, external conduction glazing, external conduction opaque, air movement gain, and infiltration gain. And here we can see the peak is at our 4240, which is 26th of June at 4 p.m. and cooling load is 951 and the Ribov temperature is 25 and the resultant temperature is 26. I think it would be easier if we show more decimal places here. Project units. Okay, I prefer to see the dots at the end. And for the temperature, we should see one decimal place. Okay, this should, yeah, okay, so resultant temperature is 26 at the peak and drive of temperature is 25. And this is relative humidity. So we have now space with all the data. If you want, we can now apply some nice coloring. So we can go to analyze and set this up. So TSD cooling load. Okay, and we could do coloring as whatever we want, like watts per square meter or temperature. And here we go. The last step is what I like to do is to show what's happened with the construction. So we can go tag all type. Okay, and now we can see all the walls are tagged. If we have view value, we can show the view value, and I think it's very neat and easy, and everyone can understand what's going on because we see visually all the components. And so thank you very much, and I hope you enjoy it, and I really hope now the other guys will start the challenge, and let's see which is the next software who can integrate well as well. And idea is to just to minimize inputting stuff in the software, just doing something from the Revit or Dynamo stuff. Okay, so I hope the challenge is open.